Hey everyone, welcome to the second part of 6.4 Hyperbolas. We are talking about asymptotes. Remember, an asymptote is an imaginary line that a graph or a curve will come close to approaching but will never actually touch. And hyperbolas actually have two. So what we're going to do is we're going to do this example. Sketch this hyperbola. Okay, it's currently not in standard form, so we're going to divide everything by 16, and you should get x squared over 4 minus y squared over 16 equals 1. Okay, there it is in standard form. We know the center is at 0, 0, because there's no parentheses. I know that A is going to be 2, and I know B is going to be 4. Now, we really haven't done much with B, but now if we're sketching this, we want to know something about B, because it'll help us sketch. Because if I were to graph this, I would say, okay, I know that X is first, so that means it's going to be horizontal. So if I were to graph this somewhere, I'd say, okay, here's my center. I could find my vertex is 2 away, so I go 1, 2 this way, 1, 2 this way, and then I could make some sort of curve this way and this way. But how curvy do I make it? How wide do I make it? That's where B is going to come into play, so we can kind of help us out that way. Alright, so what I did over here was I plugged it into Desmos. As you can see, there's the graph exactly as we had it before, and it graphed it right here. So we can see our vertices are 2, 0, and negative 2, 0. Okay. What I'm going to do actually is I'm going to use this graph. We're going to go right here. There we are. And we are going to, I'm going to just plot some points. I'm going to plot the points A, which are 2 away, right? So this would be here and here. Okay, and let's make this a little bit smaller. And then I'm also going to plot where B would be. B would be up 4 and down 4. So what I'm going to do is I'm going to go up 4 from this point. I'm going to go up 4 from this point. I'm going to go down 4 from this point. I'm going to go down 4 from this point, and I'm going to plot those. And then, just for fun, I am going to make a little rectangle out of it. That way we can say, this is a little rectangle that is made up of 2 A's and 2 B's, right? Because A is 2, so it goes halfway here. B is 4, so it goes up 4 and down 4. So we have this rectangle right here, okay? And what you'll find is that the asymptotes actually go through this point, the center, and this point, all right? So this is what it should look like. The asymptotes right here would be y equals h and k are still the center of our hyperbola, b over a if it's horizontal, or a over b if it's vertical. And how I say is, just remember it's the second one divided by the first one. So what I mean is it's going to be b over a. It's always this one divided by that one. Then we have to say which one's a, which one's b all the time. You can say it's just going to be this one divided by that one. Okay, so if we know for our hyperbola here, we know that b is 4, a is 2. So I know that it's going to be y equals, my center's at 0, 0. So really I just have to do 4 over 2x. And we can say y is negative 4 over 2x. Yes, I know I can clean that up, and I will, because they're both positive and negative 1/2. So let's go to Desmos, and we will graph this, and we'll say, okay, that is 1 over 2. Oh, hey, whoa, what's going on here? Let's get back to where I want to be. That's this one, and it is this one. We're going to say it is going to be, nope, it doesn't like that either. Interesting. Let's say it's 1. No. Well, okay, so it doesn't want me to type it in, but it would be 1/2 x and negative 1/2 x. Let's just go through and actually do it this way. Let's do the old-fashioned way of doing it by hand. So I should start from here, and I should go down 1, right 2, down 2, right 1. So I go, it's not 1/2, it's 2 over 1. So I go down 2, right 1, down 2, right 1. And there it goes to the center. Down 1, 2, right 1, down 2, right 1. And it goes through here. If I keep going down 1, 2, right 1, and I could also include this one to go up a little bit further. I can go up 1, 2 more, right 1. So it's going through these. Notice how our hyperbola does not go through this point, or it doesn't go through this asymptote. It's getting closer and closer to this asymptote, but it never actually touches. We can do the same thing here. I could start here, go down 1, 2, right, left 1, and go this way up through this point right here. And there are my asymptotes. That's what it's going to look like. So that way, if you graph those lines, then you can kind of figure out where the graph is going to be. Okay? Does that make sense? I hope so, because here is your assignment. Are you ready? Let's see if we can just get right back to it. Your assignment is to sketch this hyperbola by finding its asymptotes. And there it is. So you're going to have to factor it a little bit first. And then what I would say to do is on graph paper or something like that, make your graph, find A and B, make the box. Alright, and then you could draw your asymptotes just like that. And then you can go from vertex out and then vertex out. Alright, so then it would be fairly simple to do once you get that box. It really helps making the graph really simple. Alright, good luck.